Welcome to this video on the Agentic Markdown, SDLC. We'll explore how to synchronize Azure DevOps with offline-first, AI-orchestrated local backlogs for continuous and efficient feature delivery. There is a significant translation gap between high-level web portals like Azure DevOps or Jira, which are often manual and disconnected, and the low-level code bases where the actual work happens. To bridge this gap, we're re-architecting the system. By using an Agentic Markdown SDLC, the local Git repository becomes the source of truth, enabling native AI accessibility, contextual linking, and automated requirement refinement. In this model, the product backlog is treated as a version-controlled codebase. Epics, features, and user stories are stored as Markdown files, tracked via Git commits, and made instantly accessible to local AI agents. Each requirement file is dual-purpose. It contains YAML front matter for data and routing, Markdown body for context, and Gherkin scenarios to provide clear, executable specifications for the development process. We maintain corporate visibility through a bidirectional translation engine. Our CLI tool converts between ADO-rich text and local Markdown, mapping hierarchies and task statuses seamlessly in both directions. Consider the reality of raw requirements. In a traditional portal-bound SDLC, a vague note like this one might sit for days, waiting for a formal refinement meeting. Our approach changes this by enabling one seamless development session. This end-to-end cycle automates the flow from pulling a raw idea to syncing the final done status back to the portal. Step 1 is pulling the requirement into the IDE. The raw item is transformed into a version-controlled Markdown file, instantly ready for our local AI agents to process. Next, we use agentic auditing to expose architectural flaws. The AI evaluates the requirement against invest criteria, identifying missing details or decomposition needs immediately. In the third step, the agent helps decompose the monolithic requirement into a structured agile hierarchy, ensuring every substory includes concrete, testable Gherkin acceptance criteria. Step 4 synchronizes this refined hierarchy back to Azure DevOps. The broader organization gains full visibility into the project structure without the team needing to manually update the portal. With the requirements clear, Step 5 is the agentic implementation. The AI leverages the established Markdown context to guide the generation of the necessary code and styles. Step 6 verifies the work through automated E2E testing. We can confirm that the acceptance criteria are met, with test results generated and verified in under 30 seconds. Finally, we close the loop. Updating the local Markdown state automatically triggers async to Azure DevOps, ensuring the project board reflects reality in real time without leaving the IDE. This approach provides systemic acceleration across the entire software development lifecycle. By automating traditional bottlenecks, roles like product owners, developers, and QA can focus on value rather than manual overhead. Ultimately, the backlog is no longer just documentation. It becomes an active, version-controlled payload that drives an intelligent and efficient software delivery lifecycle, keeping your team in sync at every step of the way.